Hello friends, how are you? I hope you all are well. Today in this video I am going to explain one of the important concepts of electric field and potential, that is electric dipole. What is electric dipole? The two equal and opposite charges, if they are separated by a small distance, it constitutes an electric dipole. Two equal and opposite charges separated by a small distance constitute an electric dipole. You can say a combination of plus q and minus q. A combination of plus q and minus q. That means both are equal but opposite. A combination of plus q and minus q separated by a small distance, it makes an electric dipole. You see here, for example, this is minus q, this is plus q, this point is plus q. Suppose this is the main point and the distance from one pole to another pole we have taken 2l. For convenient, we have taken the length of the dipole is 2l, and one of the important parameter of the electric dipole which determines the strength of its influence, I can say that an important parameter of an electric dipole which determines the strength of its influence. Which determines the strength of its influence on a charge placed in its field is dipole moment. Very important point. I have written that one of the important parameter which determines the strength of its influence on a charge when it is placed in its field, in the electric field, is called the dipole moment. It's denoted by the symbol P. Since it is a vector quantity, I have given the arrow mark. Let us see. So, suppose this is the negative charge, this is the positive charge. The line passes through this negative charge and positive charges. That is called dipole axis. The line passes through minus q and plus q is called dipole axis. Okay, and the line perpendicular to dipole axis and passes through midpoint of the dipole, means this one is called dipole equator. So this is the dipole axis, this is the dipole equator. So what about the direction of the dipole moment? The direction of the dipole moment is from negative to positive. The direction of dipole moment from negative to positive, means this is the direction of this dipole moment. So mathematically I can say that this dipole moment is the product of one of its charge and the length between the two poles. One is the negative pole, one is the positive pole. So I can say that this is 2ql. So here this distance, this is the vector, that's a vector 2ql. It is the product of one of the charge q and its length is 2l. That means 2ql. This is the electric dipole moment. Electric dipole moment. What about its unity? So the charge is coulomb, the length is meter. So its SI unit is coulomb meter. Okay. So this is about the electric dipole moment, and so far as an ideal dipole is concerned, an ideal electric dipole is one in which the charge tends to infinity. Ideal electric dipole, the charge tends to infinity and the separation between them is 0. That means I can say that P equal to 2ql. This is infinity, and I can say that a point charge with zero separation. Zero separation. Point charge means you can say it has no size. It is a point with zero separation. We can say it is an ideal electric dipole. Now, let us discuss how to calculate the electric field due to electric dipole moment. How to calculate the electric field due to an electric dipole. Electric field due to an electric dipole. Electric field due to an electric dipole. So now taking a point on the dipole axis, at a point on the dipole axis. That means, see that, suppose A is the point where the charge is minus q, B is a point where the charge is plus q. Suppose here we have taken the distance between the two poles is 2L. Okay, this is the dipole axis. This is the dipole axis. Suppose P is a point. We want, it is a point on the dipole axis. I want to calculate the electric field or field strength at the point P. Suppose this point is the midpoint and the distance from midpoint to this point P, where I am going to calculate the electric field, let it be equal to R, the midpoint of the dipole and the point where I am going to calculate the electric field or electric field strength, what you can say. Okay, so from B to the point P, here to here is the R, here to here is the L, so definitely this is R minus L. Okay, from point A to the point P, this one will be L plus R. Listen carefully. See here, this is the minus Q, this is the plus Q charge at the point B, point A, point B. Suppose this O is the midpoint of this electric dipole. This is the dipole axis. I want to calculate the electric field at the point P, which is at a distance R from the midpoint of this dipole, and it is on the dipole axis. Now let us see. Suppose the electric field at the point P due to minus Q charge at the point A. I am writing this is E1. E1 is the electric field at the point P due to charge Q. I can write this is 1 upon 4 pi epsilon naught Q divided by here to here the distance is r plus L or L plus r square. Okay. So this is r plus L square. Similarly, the electric field at the point P due to charge plus Q at B will be, let it be E2 1 upon 4 pi epsilon naught Q upon, here to here the distance is r minus L. Here is the r, here is the L. So this is r minus L. So I am writing r minus L square. Between E1 and E2, which one is the greater? Definitely E2, because E2 is the influence of the charge plus Q which is nearer to the point P. So the net charge or the net field at the point P will be equal to E2 minus E1. I can write this is equal to 1 upon 4 pi epsilon naught Q upon r minus L square minus 1 upon 4 pi epsilon naught Q upon r plus L square. So I can take common how much? So I can take common Q upon 4 pi epsilon naught. This is 1 upon r minus L square minus 1 upon r plus L square. So this is equal to Q upon 4 pi epsilon naught. I am writing here, okay, see here. Q upon 4 pi epsilon naught, this is r minus L square, r plus L square, r minus L square, r plus L square. So I can say that this is r square plus L square plus 2rl minus r square plus L square plus 2rl. Okay. So this is r square plus L square. This is also minus L square. Okay. So it is better I should write here see here, this is equal to Q upon 4 pi epsilon naught. This r square minus r square cancel, L square minus L square cancel, 2rl plus 2rl, that is equal to 4rl divided by, this is r minus L, r plus L. So I can write that is r square minus L square to the power 4. Okay. Sorry, to the power 2. Okay. So a square b square ab whole square. So r square minus L square whole square, that is 4rl. I can write this is two QL into 2r divided by 4 pi epsilon naught r square minus L square square. Okay. So this 2QL I have written 2 into 2 4 QRL, same thing I have written, but I have written 2QL because it stands for electric dipole moment. Already I have said that dipole moment is the product of length and one of the charge. So I can say that this is 2rp, okay, divided by 4 pi epsilon naught r square minus l square square, okay. Since 2ql is equal to electric dipole moment. Now listen carefully. So far as atom, molecular or solid state of physics concerned, and in practically most of the time when you deal with the atomic or molecular dipole, that means their distance very less in comparison with the distance where we are finding the electric field. That means I can say that L very less than R. So I can neglect this L. If I neglect this L, then what will happen? Then electric field at the point P will be equal to 2rp divided by 4 pi epsilon naught. This r L square neglected. This is r to the power 4, or I can say that 2p divided by 4 pi epsilon naught r to the power 3. This is the net electric dipole at a point on the dipole axis. It is on one end of the point, okay. So this is the way I calculated the electric field at a point due to electric dipole, or you can say due to dipole moment. Let us see the next one. Children, don't forget to share this video. As a result, your friends also can get the benefit. Now let us see electric field at a point on the dipole equator. On the dipole equator, okay. See that. Suppose this is A minus Q, this is B, this is plus Q, okay. Q is a point on its dipole axis. In this case, you see that this is the negative charge, this is the positive charge, and at the point Q, the positive charge is there. So I have to calculate the electric field at this point. So this charge, the electric field which is here, its direction is like this. This is the positive charge. In this case, the direction will be like this, okay. Now I have to calculate the electric field at this point Q, at a point on the dipole axis. This is the dipole axis. I have taken a point Q, okay. Now this AQ and BQ both are equal. You can consider this is an isosceles triangle. Now in this case, this angle I can take it theta, this angle I can take it theta. Listen carefully. One force is acting like this direction, one force is acting like this direction, okay. So definitely the resultant force will be like this. Now let us see. So the electric field at the point Q, due to the negative charge Q at the point A, I can say this is 1 upon 4 pi epsilon naught q upon, okay, see here, suppose here to here, this is the dipole, so 2l, so I can say here to here the distance is l. Let this distance become r. So according to Pythagoras theorem, I can say that this distance will be the l square plus r square root over, or l square plus r square root over. Okay. So 1 upon 4 pi epsilon naught q divided by distance, here to here distance square. That means I can write l square plus r square. Okay. Now you see E2, that means the electric field at the point Q due to the plus Q charge at the point B also will be equal to 1 upon 4 pi epsilon naught q upon l square plus r square. So I can say that this E1 equal to E2, this is equal to q upon 4 pi epsilon naught l square plus r square. Okay. So this is an isosceles triangle. This angle theta, this angle theta. Definitely this angle will be equal to 2 theta. Okay. Now I have to calculate the electric field at the point Q. So the electric field at the point Q is equal to E1 square plus E2 square plus 2E1 E2 into cos 2 theta. Okay, I am using vector law of addition. Okay. So E1 square plus E2 square plus 2E1 E2 cos 2 theta. Okay. So what about the E1? E1 is q by 4 pi epsilon naught l square plus r square. E2 also that one. So I can say that this one, E1 square plus E2 square, both are, I can take E1 square. So 2E1 square plus 2E1 square cos 2 theta. Listen carefully. So in this case 2 I am taking common. Okay. Then how much left? Okay, 2E1 square you can take common. 1 plus 2 cos 2 theta. 1 plus 2 cos 2 theta. Okay. So E1 square, I can take it here E1. Then it will be 2 into 1 plus 2 cos 2 theta. Okay. So this is equal to E1 1 plus 2 cos 2 theta equal to 2 cos square theta. So I can say according to trigonometry 2 cos square theta. That means this is equal to E1 into 4 cos square theta, or I can say that cos theta. In this case, so I am dropping this one. E1 into 2 cos theta. Sorry, this one. Okay, minus q plus q. This is L square plus R square. This is L square plus R square. Okay. So this is the direction. Okay, it is necessary. That's why I drew it once again. Okay. So this is an isosceles. So in this case, E1 into 2 cos theta. Okay. So E1 equal to nothing but the q upon 4 pi epsilon naught. I can write this is equal to q upon 4 pi epsilon naught L square plus R square into 2 cos theta. You see that here cos theta, this is the L. So cos theta I can write B by H, means L by L square plus R square. So I can write L upon L square plus R square, since cos theta is equal to L by root over of L square plus R square. So dropping this one. Now I can say that 2ql divided by 4 pi epsilon naught L square plus R square. This is 1 by 2, this is 1, this is 3 by 2. Okay. Now this R is very larger than L, or I can say that L very less than R. Then we can neglect. Which one we can neglect? We can neglect the L. If I neglect the L, then what will happen? Then it will be equal to 2ql upon 4 pi epsilon naught. This L square will be neglected, so it square cancel, R to the power 3, or I can say this is minus P divided by 4 pi epsilon naught R to the power 3. This is about the electric field at a point on the dipole axis. Why I have taken minus P? The fact is that this one like this is like this. Actually this is the negative, this is the positive. The direction of the dipole moment is like this, but here the resultant field direction opposite like this, because this is an isosceles triangle. These two angles are equal, total 2 theta, but theta and theta, definitely the resultant will be bisector of this angle theta and its opposite direction. So the answer will be coming minus P divided by 4 pi epsilon naught R to the power 3. So, in the previous one, when I calculated the electric field at a point on the dipole axis, that time we got 1 by 4 pi epsilon naught P by R to the power 3. Previous case. So, this is the electric field at the point P. Okay. So, this is about to electric dipole. So, I hope that you might have understood this concept perfectly. So, children, I hope that you might have subscribed. If you have not done, you do it as early as possible, which will be convenient for you to get the alert as early as possible. So, until the next video, bye.